Welcome to PreMath. In this video, we have got this rectangle ABCD along with this diagonal AC fully inscribed in a quarter circle with the center B, as you can see in this given diagram, such that this segment BC equal to this segment CF, and this side CD is 6 units. And now our task is to calculate the area of this green shaded region, this area and this area combined. Please don't forget to give a thumbs up and subscribe. And please keep in mind that this figure may not be 100% true to the scale. Let's go ahead and get started. And here's our very first step. Let's focus on this quarter circle with the center B. And we can see these two segments BC equal to this segment CF. So therefore I'm going to label this segment BC as X, then CF segment length is going to be X as well. And furthermore, we know that this BF is the radius of this quarter circle, and the radius of this quarter circle is going to be X plus X. I'm going to label the radius as lowercase r is going to become 2 times X. So thus the radius lowercase r of this quarter circle is going to be 2 times x. And now let's make an observation. We can see that this AC is the diagonal of this rectangle. And furthermore, we can see that this BD is the diagonal of the very same rectangle ABCD as well. So therefore, this diagonal length AC is going to be equal to this diagonal BD length. And now we can see that this BD is, as a matter of fact, is the radius of this quarter circle. And we know the radius of this quarter circle is 2 times x. So therefore, this BD length has got to be radius 2 times x. And since these diagonals are equal in length, so therefore the length of this diagonal AC has got to be 2 times x as well. So thus this diagonal AC length turns out to be 2 times x. And now we can see that this segment BC equal to this side AD. If this is x, then this AD is going to be x as well. And now let's focus on this right triangle ADC. And we are going to use the Pythagorean theorem on this triangle to solve for x value. And here's our Pythagorean theorem: a square plus b square equal to c square. In our case, our hypotenuse is 2x, whereas our two other legs are x and 6. So let's go ahead and fill in the blanks in this Pythagorean formula. So we got x square plus 6 square is going to be equal to 2 times x whole square. Let's simplify. That is going to give us x square plus 36 is going to give us 4 times x square. And now I'm going to subtract x square from both sides. So therefore we can see this x square and negative x square is gone. So therefore on the right hand side, this part on the right hand side is going to give us 3x square equal to 36. And now we are going to divide both sides by 3 to isolate x square. Since 3 and 3 is gone, so therefore x square turns out to be equal to 12. And now we are going to undo this square by taking a square root on both sides. So therefore our x value turns out to be equal to 2 times square root of 3 units. So thus our x value turns out to be 2 times square root of 3. And we know our radius r is 2 times x. So therefore our radius lowercase r is going to be 2 times, and x value is 2 times square root of 3. So thus the numeric value of lowercase r radius turns out to be 4 times square root of 3 units. So therefore this segment BC turns out to be 2 times square root of 3. And likewise this diagonal AC turns out to be equal to 2 times x, means it's going to be 4 times square root of 3. And here's our next step. Let's focus on this right triangle ABC. And I'm going to label this angle ACB as angle theta. And now let's recall the trigonometric ratio. Cosine of theta is always equal to adjacent divided by the hypotenuse. So for this green triangle ABC, this side BC is going to be our adjacent, whereas this diagonal AC is going to be the hypotenuse of this green triangle. So therefore our cosine theta value is going to be equal to, our adjacent side is 2 times square root of 3 divided by hypotenuse is 4 times square root of 3. And here we can see this square root of 3 and square root of 3, they are gone. And this 2 divided by 4 could be reduced to 1 divided by 2. So therefore cosine of theta turns out to be equal to 1 divided by 2. So therefore theta is going to be equal to cosine inverse of 1 divided by 2. And now we know that cosine inverse of 1 divided by 2 is always 60 degrees. So therefore our angle theta turns out to be equal to 60 degrees. So thus our this angle turns out to be 60 degrees. And in this next step I am going to connect this center B with this vertex D, as you can see in this next step. And now let's make an observation. We know that this diagonal AC equal to this diagonal BD. So therefore this angle is going to be congruent to this angle. If this angle is 60 degrees, this angle has got to be 60 degrees as well. And furthermore, we know that this angle is 90 degrees and this angle is 60 degrees. So therefore we can see this remaining angle ABD has got to be 30 degree angle. And now let's make an observation. We can see that this green shaded triangle ABD area, we are talking about this green shaded triangle ABD area, is going to be equal to the area of this other right triangle DAB. We are talking about this DAB area. So therefore it is sufficient to say that this green shaded area is going to be equal to the area of the sector ABD. We are talking about this ABD sector area. So therefore now our task is to calculate the area of this sector ABD. And now let's recall the sector area formula. Area equals to angle theta divided by 360 degrees times pi r square, where r is the radius. And in our case our angle theta is 30 degrees, whereas our radius r is 4 times square root of 3. So therefore our sector ABD area is going to be, our angle theta is 30 degrees divided by 360 degrees times pi times our radius r is 4 times square root of 3 whole square. And now we can see 30 degrees divided by 360 degree reduces to 1 divided by 12. And likewise the square of 4 times square root of 3 is going to be 48. So therefore this could be written as pi divided by 12 times 48. And if we simplify furthermore, that is going to give us 4 pi square units. So thus our sector ABD area turns out to be 4 pi. And we know that green shaded area equal to the sector ABD area. Therefore this green shaded area has got to be 4 pi square units. So thus after all the calculations and manipulations, our green shaded area turns out to be 4 pi square units. And that's going to be approximately equal to 12.57 square units as well. And that's our final answer. Thanks for watching, and please don't forget to subscribe to my channel for more exciting videos. Bye.